I've posted a stoichiometry plan previously, and I decided to add in more paths to make it comprehensive, so that gives us the Stoichiometry Plan 2.0. In this video, which is part 2 of the stoichiometry series, we're going to look at 3 questions, and using the improved plan, we'll figure out how to set up the solutions correctly. Here's the new plan. In time, I'll add in the volume to mole conversion, but right now, this is good enough to solve most stoichiometry problems. Notice there is A and B in the plan. They simply refer to 2 different substances. It'll make more sense soon when we look at some examples. For each conversion, there are 2 arrows. For example, to go from grams A to moles A, we need to divide by the molar mass or the atomic mass of A. And to go from mole A to grams A, we need to multiply by the molar mass or atomic mass of A. So here's what we're going to do. We'll look at 3 questions and figure out the steps required to solve those questions using this plan. This is our first example. The question is asking us to calculate the number of atoms present in 0.75 mole of aluminum. Notice, there is only one type of substance mentioned here, which is aluminum. That means we're only working with substance A. So what information do we have? Well, it's 0.75 moles of aluminum. We will label that as the starting point. And what does the question want us to find? It's the number of Al atoms, and that will be our ending point. From the question, we've already figured out what we have and what we want to find. So let's tag our start and end point in this plan. Just a quick note, atoms and molecules are all parked under particles, so that's why our endpoint is particle A. So the question starts us off with 0.75 mole of Al, that's our starting point, mole A. To go from mole A to particles A, we'll need to multiply with the Avogadro's constant. So that means there's only one step that's involved in solving this problem. All we have to do is multiply the given number, which is 0.75, with Avogadro's constant, which is 6.02 times 10 to the power of 23, and that will solve the example 1 question. And let's look at another question that will require more than one step. Here's our second example. The question is asking us to calculate the mass in grams for 1.73 times 10 to the power of 24 Na atoms. The whole question only involves the same substance, which is sodium, Na. That means we're only working with substance A, like our previous example. So what information do we have? Well, it's 1.73 times 10 to the 24 Na atoms. That will be our starting point. And what does the question want us to find? It's the grams of Na, and that will be our ending point. Here's what we have and what we want to find, so let's tag our start and end point. Since we're dealing with only one substance in this question, that means we'll be working with only substance A on the left side of the plan. The question starts us off with 1.73 times 10 to the power 24 Na atoms. That's particles A. Since our endpoint is grams A, so we'll need to go through mole A first to get to grams A. To go from particles A to moles A, we'll need to divide by the Avogadro's constant. And then from mole A, we'll need to multiply with the atomic mass of Na. Looks like it will take 2 steps to go from particles A to grams A. To set up the solution, we'll first need to divide with the Avogadro constant, which is 6.02 times 10 to the 23. And then, for the second step, we'll multiply the answer we get from step 1 with the atomic mass of Na, which is 22.99. That will solve the question in example 2. Moving on to a more challenging question. Here's our third and final example. The question is asking us to calculate the grams of zinc chloride, ZnCl2, that will be produced from 38.0 grams of HCl. So what information do we have? Well, it's 38.0 grams of HCl, that's mass A. That will be the starting point. And what does the question want us to find? It's the grams of zinc chloride, which is grams B, and that will be our ending point. So you might be wondering, how do we know which is substance A and B? Well, in the event that the question has 2 substances mentioned, we just call the substance that we have information on as substance A, which in this case is HCl, and then the one that we need to find information on, we'll just call that substance B, which in this case is zinc chloride, ZnCl2. So we have 38 grams HCl and wants to find grams of zinc chloride. So let's tag our start and end point in this plan. The question starts us off with 38 grams of HCl, so that is grams A, and our ending point is grams B, which is a few steps away from grams A. So we need to go from grams A to moles A by dividing with molar mass, and then mole A to mole B by multiplying with the mole ratio, and finally mole B to grams B by multiplying with the molar mass. Looks like it'll take 3 steps to go from grams A to grams B. To set up the solution, we'll first need to divide the given mass with the molar mass of HCl, which is 36.46. And then for the second step, we'll multiply the number we get from step 1 with the mole ratio. From the given balance equation, coefficient B, which is the number in front of zinc chloride, it's 1. And coefficient A, the number in front of HCl, is 2. So the mole ratio is 1/2. And last step, we'll multiply with what we get from step 2 with the molar mass of zinc chloride, which is 136.286. That will solve example 3 question. If you need a recap on calculating molar mass, I'll link a video on the top. To recap, when solving stoichiometric questions, first thing is to read the question and find out what we have and what the question wants. Then we'll need to find the start and end point on the plan. And lastly, we'll find the path that will lead us from start to end. We write out the steps that are involved, and then we solve them. I'll post more videos on solving stoichiometric questions using this plan. Do watch out for them. Hope you find the video helpful. Do subscribe, and thanks for watching.